So in the interest of time, I'm not going to come around and check the homework assignment. I think our time is better spent discussing the homework assignment. So you're fine.
No, I don't interrupt.
I appreciate your being mindful, but okay. So all of the answers were on the sheet except for number 1. So let's go over number 1. Okay. So for number 1, you were given these graphs. There were 4 velocity time graphs and 4 position time graphs. And for each one, you needed to tell me the direction the object was moving, if the speed was increasing or decreasing, and if the velocity was increasing or decreasing. All right? I see people make the same mistakes on these time and time again. All right? With the velocity time graphs, I see the same one mistake over and over again, and then a different mistake with position time graphs. So anyway, when you're doing this, the first thing you have to do, it sounds silly, but take a minute and pause and ask yourself, what kind of graph am I looking at here? Is it a velocity time graph or a position time graph? Okay, because the rules for them are different. All right, so with that in mind, let's run through these. All right, so here we go. Let's do the velocity time graphs first. All right, so the first thing in red, if the object, we got to decide if the object is moving forward, backward, or not moving at all. All right, so I don't want to say this without giving away the answer here. All right, so suppose I've got 2 objects. Object A is moving forward at 50 miles an hour. Object B is moving backward at 50 miles an hour. When I write that down on my paper, how am I going to indicate that distinction? Sure, Lucas, is that a hand up or just up?
Sure, negative number.
Good, negative, right? So the way that we indicate direction with velocity is by positives and negatives, right? So with that in mind, remember, the horizontal axis here represents a velocity of 0. So these velocities, are they positive or negative? Negative, which means that that object is moving backward, right? Now, please make sure you hear me say this. The reason this is moving backward is not because it's sloped downhill. It's negative, or it's backward because it's negative numbers. All right? Over here, the velocity is positive, which corresponds to moving forward. Now, here's the one that people always get wrong. Over here, the velocity is positive, and therefore it's moving forward, right? It's got a positive velocity and then a decreasing positive velocity. But positive velocity indicates moving forward. Please, please, please don't be the person who looks at this and goes, oh, it slopes downhill, it's going backward. All right? That would be true for a position time graph, but not for a velocity time graph. Does that make sense? We're good? All right. So finally, then the last one, what do you guys got? Backward, right? And we know that because that is negative velocity. Cool. All right. So the next 2 things we got to decide is whether the speed and velocity are increasing or decreasing. Let's do velocity first, just because they're velocity graphs. Okay, if you're looking at a velocity graph, what's the graph going to look like if the velocity is increasing? Show me with your hands. That's increasing velocity, right? And what's decreasing? That, right? Okay, so we'll do this in blue. How about velocity? So this one has velocity decreasing. Over here we've got velocity increasing. Here the velocity is decreasing, right? It's going downhill. And over here it's increasing. Cool? Problems with that? All right. So here's the other mistake people make with these velocity graphs. Just because your velocity is increasing doesn't mean your speed is increasing. Because velocity can be negative, but speed cannot. So there are 2 ways to figure out what's going on with the speed. Remember, your speed is the same as the velocity, but you get rid of the negatives. It's basically absolute value, right? So what would the absolute value of this function look like, you guys? Can you show me with your hands? We go up, right? So if speed is the absolute value of velocity, then my speed is increasing, right? Here, the absolute value stays the same, so my speed is increasing. Here, absolute value stays the same. But how about this one? That one's going to flip over, right? Okay. So that's one way to do it. All right, and a lot of people like that method, and if you're in that boat, then great. The way I always like to think of it is this. What's the smallest speed an object can possibly have? 0. Is that true of velocity? No, what's the smallest velocity? Negative infinity, right? Okay, but the smallest speed you can have is 0. So you're slowing down if your velocity is going towards 0. So here's my velocity going towards 0 or away? Away. So that means that my speed is increasing, right? Because you're moving away from the slowest you can go. In other words, speeding up, right? Here, your speed is increasing. Up over here. Decreasing. And here, your velocity is negative, but still getting closer to 0, so you're still slowing down. All right. Questions about A, B, C, or D? Pretty good? Alrighty then. So, let's move on to the position time graphs. So, same thing, red, green, and blue. So red, we got to decide for each of these position time graphs if the object is moving forward or backward. So, same logic, just positive or negative? No, what does the position graph look like if you're moving forward, you guys? Show me the hands. Up, right? And if you're moving backwards? Downhill, right? So, forward or backward? Backward, because it's going downhill, right? How about over here? Forward. Forward. Backward. Blue? Okie doke. Speed. So as your object speeds up, the graph gets more steeper, right? So is this getting more steep or less steep? More steep. So that means that the speed is increasing. How about over here? Speed is increasing because it's getting steeper. Here it's getting less steep. That's decreasing speed. And here, less steep again. That speed is decreasing. Cool? All right, and finally, velocity. You just got to think about this. We're going backwards and speeding up. Again, we've done this a bunch now, right? We're going backwards and speeding up. So that means your velocity is getting more negative, which means the velocity is decreasing, right? So the acceleration would be negative, right? Over here, the velocity is positive, and you're going faster, so it's going to get more positive. So that's velocity increasing, right? Over here, you're going forwards and slowing down, so your velocity is decreasing. Over here, your velocity is negative, but getting more negative. So that means your velocity is, going backwards and slowing down, so it's getting less negative. So increasing. Any questions of those, you guys? All right, now the last thing I want to point out, so when you guys did the lab the other day, you guys were pushing the cart around, and on your screen there was a position time graph and a velocity time graph, right? Did the two graphs look the same? No. But they described the same motion, right? Both graphs were for the same cart, they just were graphing different things. One was position, the other was velocity. The same is true here. I don't know if you guys noticed this, but the way that I set these up on the page, backwards, speeding up, decreasing velocity. So these two graphs represent the same motion, except that this one's velocity and this one's position. Similarly, these are the same graphs, and these are the same, and these are the same. I shouldn't say same graph, same motion. Oh no. There we go, same motion. Does that make sense, you guys? Any questions about number one? Is there a weird noise? Okay. No? All right, everybody good? All right, number two. Answers were on the sheet. There was one mistake on the answers. 2B. Oops. 2B. the position time graph was right. So it said an object begins at a position of 10 and then goes backwards at 2 meters a second. So it goes like that. So that one's good. There's something wrong with my velocity graph though. Can you see it? The velocity should be negative, right? -2, right? Because you're going backwards at 2 meters a second. So I apologize for the mistake. Pretty good? How come the velocity is constant? Well, I mean this in a non-snarky way. I think the problem tells you that it's constant. Yep, constant velocity of 2. You good, Abby? Yeah. So the position is changing. That's why the position goes down, right? But the velocity is constant. Because it's going backward. Cool. Unrelated to anything at all. I think I was probably, I don't know, in my late 20s when I discovered that neither the word backward nor forward have an S at the end. I just thought it was going backwards. It's not. Just backward. You know that thing. There was a hand up that had to do with physics, not my weirdness. What do you got?
So like for E and F, like there's no answer key for it, but like would the graphs basically be the same except for F would like start?
They're the same as C and D, yeah. Good. All right. Does anybody want me to draw any of these? In my other classes, I did D. You want me to do D real fast? Okay. All right. So, something was brought to my attention when I went over this one last hour that I honestly didn't realize, and I see now why it was confusing. So some of D, I think part of what made it confusing was the wording, because it says Roy is at a position of 0 and he's moving forward at 15 meters a second, but then begins accelerating. And so I think some people were thrown off because they didn't know how much time passed between this and the accelerating. So I wanted it to be that at the instant the problem begins, he's moving this fast and accelerating. So I think this but then, I think that is misleading. So I think that fixes it. So I'm sorry if that was what messed you up. I will go back and reword that. Follow? Okay, so with that in mind, let's see if we can graph this thing and make some sense out of it. The position time graph. So position time. So let's see, it says he's at a position of 0, and then he's moving forward. So the graph is going to do this. Is it going to just be a nice straight line, you guys? No, because he accelerates, right? So that means it's going to curve in some fashion. So right now I'm feeling a little like I don't know what to do with this position time graph. So I'm going to put the brakes on, no pun, and I'm gonna hold on this and come back to it. And let's look at the velocity time graph, and maybe we can make some sense of the velocity time graph. So the problem tells me that my velocity begins at 15, right? And it also tells me that the acceleration is -5. So what does that mean that my velocity's got to do every second, you guys? Decrease by 5, right? So let's put some numbers on here. Let's see if we're decreasing by 5. Let's number by 5s. So we'll call this 10, and 5, and 0, and -5, and -10, and -15. And let's put in some time. 1, 2, 3, 4, 5, 6, 7 seconds. So at time 0, my velocity is 15. 1 second later, what should it be? After 1 second, shouldn't it be 10? Right? Because every second it goes down by 5. So then we're going to be at 5, and then 0. And then -5, and -10, and -15. So to me, it looks like the velocity time graph is going to be, despite the fact that that's all wavy, a nice straight line. All right, so is everybody okay with the velocity time graph? I got that. Cool? All right. So what's this telling me? Let's see, at the beginning, it's moving forwards at 15 meters a second, and then it goes slower and slower until it stops after 3 seconds. So, let's see. it's moving forwards and it goes slower and slower and slower and slower and slower until it stops. And then what does it do? Then it goes back faster and faster and faster and faster. So what does this point represent? That's where it stops. That's where the velocity is 0. And we know that happens after 3 seconds. Aha. 1, 2, 3, 4, 5, 6. Does that make sense or no? All right, so then I think the only other thing we need to do, it says to, where possible, put numbers on your axes. So let's at least figure out this position here. So we don't have an equation for position, but we do have an equation for displacement. So I want to find out what the displacement is between here and here. So for that red time interval, let's write down the stuff we know. What's the stuff we know? Initial velocities, 15. We know the acceleration is -5. We know 2 other things. Time is 3 seconds, and the velocity at the end of that time is 0. So you ought to be able to use any of the displacement equations I've given you. Figure out your displacement. Probably the easiest one to do would be, I don't know, whatever. Maybe that guy. And it gives you 22.5 meters. Does that make sense, you guys? Yeah. What's up, Rick?
And stuff like that, do you want like points?
So if this was a test, I'd give you graph paper. And yeah, when it's, I mean, the direction said where possible use numbers. So like in my mind, at least finding, you know, the important points. So intercepts, you know, point, what is it called, a vertex? Vertex, right? Okay. Vertex. Does that make sense? Okay. And because you're limited on time on the test, I probably won't have you do a ton of graphing. If I do, it'll be real simple, just like super quick, sketchy stuff. I'm guessing the test will probably lean more in the direction of like the next 2 problems, which is here's a graph, analyze it. So we should probably move on to that. So are there questions on any of this? Does anybody want me to say anything more about numero 2? It's not how you say 2 in any language. We're good? Okie dokie. Number 3 is basically the same. No. Okay, graphs. Here we go. Answers were on the sheet. One tiny little mistake. My answer to letter N is 100% wrong. It says, during what time intervals is the object's velocity increasing? So look at the graph, you guys. When is the velocity increasing? Or show me with your hand. What does the graph look like? Right? Like this. So it's increasing right there. So what is that? 14 to 22 seconds. Yeah. And the answer said something dumb. So I don't know what I did. All right. So apart from that, what do we need to talk about here? Which one? Oh, yeah. Yeah, so N, the answer to N should have been, what did we just say, 14 to 22? Sam, what's up?
What was that answer to O?
Oh.
Because it wasn't on the O.
What? I don't know what I did with those answers. Let's see. O says, during what time intervals is the object's speed increasing? Can you show me what that looks like with your hands? No. Right? It's got to be moving away from 0. So this is increasing speed, right? Because it's moving away from 0. Here the speed is constant. Here it's moving towards 0. So slowing down, slowing down, slowing down, slowing down, slowing down. And then speeding up. I think what I actually had as the answer for N should have been the answer to O. So from 0 to 10 and 18 to 22. Sam, does that make sense? Okay. Is everybody happy? Shoot. Let's not worry about P. I won't give you anything like that. That's really more of an AP question. So yeah, don't worry about that. Oh. Sorry, whoever's listening to this on YouTube. Like my job. What? D, as in dog? D, find the displacement during the first 10 seconds. Yes, I can do that. So for part D, it wants to know the displacement for this chunk, right? For the first 10 seconds, it wants to know the displacement. So I don't even know who asked about this one. Okay. So somebody tell me something I know about those 10 seconds. Somebody said velocity. Tell me about the velocity. What is it? Okay, it's changing, right? So the idea is I know my initial velocity is 0, and I know my final velocity is -40, right? Oop. All right, I know at least one other thing. I know that 10 seconds worth of time pass. You can, just by looking at the graph, you can find your acceleration. It looks like it goes down 4 every second, right? Now, I will say I would be careful about this because, I mean, on this graph, like if you check every second, it's consistent, but just make sure that it's exact. Okay? All right, so is everybody okay up to there? Abby, you good up to there?
I figured out how to say it.
Oh, okay. Everybody good? All right, so once you know that, you got to find your displacement. So probably the easiest way to do it would be to use this guy. Right? So your average velocity is going to be what? -20 times 10 is -200 meters. Why does it make sense that my displacement turned out negative? Not because it's going down. The velocity's negative. The velocity's negative, which means we're going backwards. Okay? For this chunk over here, do you think my displacement would be positive or negative? Positive, because those are positive velocities. You're moving forward. Cool? All right, what else do we need to talk about from 4? Yeah, I. Find the displacement from, yes. Oh, I take back my excited and replace it with just a, never mind, I'm going to shut up. Okay, I thought it was a different problem.
I think I just put in the wrong number.
Yeah, I mean, you're trying to find the displacement from 14 to 18 seconds. So it's almost the exact same thing. Your VI is -40. Your VF is 0. Your time is 3 seconds. So find your average velocity and multiply by time. You gotta get, what, -60 meters?
But it says negative.
Times 4.
Oh, because it is.
Oh, right, 4 seconds, my bad. Sorry, I was thinking it's starting at 15. Thank you. 4 seconds. Cool? All right, anything else on this page, you guys? I feel like there was another one that my other students asked me to do in my other class. Oh, here. F. F says, what's the acceleration after 12 seconds? F, what's the acceleration after 12 seconds? What's the velocity doing at that point? It's constant. So what's the acceleration? 0. Right? Acceleration is the rate at which your velocity is changing. Well, look. What's the velocity doing? It's not changing. And therefore your acceleration got to be 0. Good? I feel like you should be able to say bless you when somebody coughs. Let's start a revolution, kids. All right, are we good? All right. Anything else on this page? Going once, 2, 3, sold. Here we go. Last problem. Position time graph. Answers were on the sheet. I think they were actually all right. Any questions on A through H? A through H. A through H.
Oh.
Sam. E. Find the velocity after 3.8 seconds. I am super glad you asked about this one, Sam. And then Lauren, you had one too, yeah? Same one, right on. Excellent. So question E wants to know the velocity here-ish. And why is it, I don't mean this in a snarky way. Sam, why was this hard? Because I don't know, after 3.8 seconds, I don't know what that coordinate is, right? All right. Describe the line, shoot, I said something there. Describe the curve at that point to me. What does it look like? It's a straight line. And what kind of graph is it? Position time graph. So when you've got a position time graph, if it's a straight line, what's the significance of that? You're good. Well, the position's not constant. You're okay. I'm going to give you a second to think, because I know you know it. Oh, now I just put the extra feet out. Sorry.
Okay, second time's happened.
Oh, I'm sorry. So you started to say it. Talk to me about the position. It's a straight line. So what's the position doing?
It's going down.
But the fact that it's a straight line tells you something about how the position is going down. See it? No? Something's constant. It's going down at a constant rate, right? So in other words, every second the position changes by the same amount, right? So what's the physicsy way of saying that every second your position changes by the same amount? Constant velocity, right? Okay, so what I was trying to get you to say is constant velocity. Okay? Sorry, I didn't mean, I know there's a lot of like that. All right, so straight line, right? When you've got a position time graph, you guys, a straight line indicates constant velocity. All right, so the problem says what's the velocity after 3.8 seconds, but there's nothing magic about 3.8 seconds. Find the velocity in here anywhere. Because it's always the same, right? So what am I really asking you to do? Find the slope, right? So pick 2 points and find the slope. So let's pick 2 points that are relatively easy. Well, let's see, right here at 4 seconds, it's close to 3.8. I see that my position is, what is that, 26? I don't know, these are dumb numbers. Why did I pick these numbers? I'm going to stick with it, though, damn it. All right, no. So there's 1 point, and at the beginning of the time, my position was 50. So velocity is displacement over time. So between here and here, my position decreases by 24. And that took me 4 seconds. That's -6 meters a second. Sam, does that make sense? Or, for that matter, maybe this is what Lauren's going to say.
No.
You could also just go, oh, well, every second my position decreases by 6. 6 meters a second. Does that make sense? Okay, you are not the only one who had a hard time with that. But the thing that's weird about it is, if I just said what's the average velocity, it would have been easy. But I ramped up the difficulty one little bit by asking for instantaneous. That's tough. Lauren, what do you got?
You asked, so.
Yeah. Everybody go to D? Ha ha ha. All right. F says, what's the acceleration after 3.8 seconds? So, Lauren, what was the whole crux of the discussion I just put Sam through? So what's the acceleration? Let's rewind, let's take a step back. Do you remember what the definition of acceleration is? So if your velocity is constant, 0. Does that make sense?
Yeah.
Constant velocity means 0 acceleration. Right? Because your velocity is not changing. Follow? Good. You guys are asking good questions. These are the ones people always make mistakes on, and other people haven't asked. So I'm super glad you're asking. Cool with that? All right. Anything else up through H? Okay, Abby asked about J. Am I safe in assuming I should probably do I also? Okay. All right. I and J were easily the hardest ones on here, and if they're the only ones you struggled with, you're in great shape. Those are definitely on the difficult side of things. All right, I says find the acceleration between t equals 15 and t equals 25 seconds. So here's my time interval, this green chunk here. Let me get rid of all this other green so you don't think that one has anything to do with the other. All right, so we're looking for the acceleration during this chunk. So in order to do that, we need to start by writing out some stuff we know. So, oh wait, we know who said that. We know that Abby said we know the displacement. How do I know the displacement? Yeah, let's see. My starting position was -10. My ending position is +20. So my displacement is 30 meters. All right, cool. That seems useful. We know the time has got to be 10 seconds, right? 15 to 25. That's 10 seconds. And then, so if that was all you knew, then you're kind of stuck. You could find your average velocity, right? Displacement over time, you get 3, hooray. That's not what I wanted to know. I wanted to know the acceleration. So we need to know at least one more thing. So I'm going to let everybody think for a second, and then I'm going to ask Drew what other thing we know, because I know that he knows, because I heard him say it a second ago. But we do know one other thing. And as you're struggling to think about it, what are the choices? Let's see. Well, we're looking for acceleration, so you don't know that. There's only 2 other variables, GI and VF. So do you have an idea of what thing we might know, Gianna? We know that, Drew, is that what you said too?
Yeah.
Yeah, what is it? What do you got, Gianna?
0.
0, Drew? Yeah? Why is I'm looking at it, why isn't it -10? Why isn't the initial velocity -10? That's position. So Gianna, defend yourself. Why is the initial velocity 0?
Between 10 and 15, there's no change in position.
Good. Yeah, look. Between here and here, position stays constant. That means you're not moving, 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 not moving. And then you start moving. So you started out with an initial velocity of 0. And now we just got to find an equation that has acceleration in it. So A equals something. So I think the easiest way to do it is to use this guy. 1/2 AT squared plus VIP and solve for A. Cool? So if you picked up on that, good job. That was super. Cool? All right. And then when do we get out? 09? Ooh, neat. I have 6 whole minutes. I'm only going to use 2 of them. All right. Is everybody good with this? That was tough. So if you didn't get that, don't beat yourself up. Same with J. All right. J says, what's the velocity at 20 seconds? So J wants to know the velocity right here. So 5 seconds after this. So now we're looking at a new time interval. So for that red time interval, the stuff I know is, I know my initial velocity, 0. I know my acceleration, because I just found it in the previous part. It turned out to be 0.6. And I know my time is 5 seconds. Why isn't it 20? Yeah.
So are we finding the instantaneous velocity at 20?
Yes.
Oh, okay. Then why are we doing the time interval? Why are you doing just like rapid? You know what I'm saying?
Because we're trying to find the velocity at 20 seconds, so where that star is, right?
Yeah.
But because it's an instantaneous velocity, and it's a great question and super important, so let me pause there for a minute. Does everybody understand that that's what we're looking for? An instantaneous velocity, not an average? All right. So because we're looking at an instantaneous velocity, we need to pick an interval for which that's either the starting or ending velocity.
Gotcha. Okay.
Make sense?
Mm-hmm.
So that I can label it as either VI or VF. And just VF is usually easier. So now I know my VI, my A. Does everybody understand why I chose my time to be 5 seconds? All right, and then find VF. I think it gives you 3 meters a second. No, yes, 3 meters. Yeah. Good, you guys? Questions, issues, concerns? How we feeling?
Could you spell that P for velocity?
Oh, yeah. I'm going to cheat. Don't do what I'm about to do. This is bad form. All right. right, I'm going to recycle my axes. So the idea is, from here to here, my velocity is constant, right? I think we figured it out before. It was -6, right? So your velocity's -6 for the first 10 seconds. Good? Then, between 10 and 15 seconds, the velocity is 0, right? So it kind of jumps to 0. This is sloppy, don't do that, but that's, you know. And then after that, we knew that the acceleration was 0.6. So whatever, just go up by 0.6. It's going to go something like that. Cool? All right, so tomorrow is your time. If there's stuff you're struggling with, ask me for help. All right, real quick question. I have not made a decision on this yet. My original plan was to just let Wednesday be a Q&A day and to make the homework due. Would you guys rather just have that more time to work and ask individual questions?
Yeah.
Okay, that is not yet decided. I will make a decision about that tomorrow, first hour. All right? Final does that make sense? So that's like a big, super important distinction that, like, between here and here, it's not your position. Ooh, I will stop recording. Somewhere. There we go.